So today's lesson is on balancing chemical equations. Now this is kind of fun because it's kind of like a little puzzle, and you're trying to solve a puzzle by making sure that you have the same number and type of atoms on your reactant side of your chemical equation and versus your product side of your chemical equation. And I'll explain a little bit more about why we're doing this on the next slide. So why do we balance chemical equations? So the one thing is we want to make sure that we honor the law of conservation of mass, which is that matter cannot be created or destroyed. So we need to have the same amount of material on our reactant side of our chemical equation versus our product side of our chemical equation. And also the thing is, we're going to use balanced equations later on to help us solve a stoichiometry equations. Think of it this way. If you needed to understand how much flour to buy if you wanted to make 40 pizzas, you need to know what the ratio of flour to pizza is. And by doing a balanced equations, you're going to get that information. So how do we do that? Well, the total number of atoms for each element must be the same on the reactant side of the equation versus the product side of the equation. Remember, the reactant side is the left-hand side, or before the arrow, and the product side is the materials after the arrow, or on the right-hand side of the chemical equation. We can only change the number of atoms by altering the coefficient in front of a formula. Remember, we can never change the subscripts. By changing the subscripts, we actually change the chemical composition of that material. So the only thing we can change is the coefficient, which is the number in front of the molecule or formula unit. Okay, so there's a little bit of a process that goes on here, like anything in chemistry, but the bottom line is it's kind of trial by error. But as you will see when you start practicing this more, you will get good at it, and you will see little trends and little tricks. So let's see how we start. How do we balance an equation, the fundamental steps. First is we're going to do an initial atom count for every type of element on the reactant side and the product side. Once we understand what the number and type of each element and atom is, we are going to then change the coefficients of a reactant or product species until the number of atoms on each element is the same in the reactants and products. Now, we may only have to change one thing. We may change coefficients on all of the products and reactants. Only some of them we only have to do one thing change, right? We're going to multiply this new coefficient by the original count to find our new number of atoms. All the elements in the formula must be adjusted if a coefficient is altered. Don't forget, when we put a coefficient, which is the number in front of a molecule or a formula unit, everything in that molecule and formula unit gets adjusted. In the end, our coefficients must be in the lowest whole number ratio. You've seen that before. There are some hints here. Save free elements, in other words, like if an element stands by itself, like sodium, potassium, oxygen, things like that. We save them for last because they're the easiest to balance. We're going to separate elements if they appear in multiple formulas, right? And I'll show you what that means in a minute. And if we have a polyatomic ion and it's not changed from one side of the reactant to the products, then we're going to try to keep those in check. And we'll do them in teams, 2s and 3s. And we'll get into that, how that works in a few minutes. Okay, so let's see how this works in real life. Now we're going to do some simple ones first, and then we're going to get more complex. I'm going to give you 4 examples. So the first thing I always do is, again, we're going to count the number of atoms for each thing. So I always draw a line down the middle to separate the reactants from the products. So I'm going to start off by counting each element here. We have a potassium and iodine. So let's count them up. So my potassium, I have 1 atom. And then my iodine, I have 2. Okay? Remember the 2 here, that's 2. Okay, now let's go to the other side. Potassium, I have 1, and iodine, I have 1. Okay, so this is fairly straightforward now. Everything's balanced except for the iodine, so let's balance that first and get that done. Okay, so remember, the only thing we can change is the coefficients. So in order to do that, since I have 1 here and 2 here, I've got to increase this to 2. And the only way to do that is to put a 2 right here. So let's do that. And that throws everything off a little bit, right? Now we have 2 here, which is good, but we also have 2 potassiums, right? So now we're going to have to go back and balance the potassiums. Now the nice thing about it is potassium's all by itself. So whatever we do here affects nothing else because it's all by itself. Potassium here doesn't have another element attached to it. So you're just going to change the number of potassiums on this side. So let's do that. So we have 2 here, we need 2 there. So let's just put a 2 here. Let me erase that real quick. Put that in red. All right, so now there we go. So let's see here. Now we've changed that to 2 now. And let's see if we've balanced it. So we have 2 potassiums here. And we have 2 over here. Good. And we have 2 iodines here and 2 iodines here. So good. So my final balanced equation is 2 potassium atoms plus 1 iodine molecule yields 2 potassium iodide formula units. Remember, this is a ionic, so therefore it's going to be a formula unit, not a compound. All right, same thing with the next one. This one's a little bit more complicated because now we have 2 elements that are combined and they're in multiple ratios. So let's draw our thing down here again. And now we're going to say there's 2 nitrogens, and there they are right there. And then on the other side we're going to have hydrogen is also equal to 2. And then I go to my product side, and we only have 1 nitrogen, so we just put N equals 1, and then hydrogen equals 3. Okay, so many ways that we can approach this. We can first try to balance the hydrogens, or we can try to balance the nitrogens, right? So let's just do the balancing of the nitrogens first, right? So we have 2 here and 1 here, so the only way to get 2 here is to put the coefficient 2 in the front here. So let's do that. Okay, now we have to recount everything. So this is now 2, but now it's 2 times 3 H's, which is 6. So we've got to make that 6. All right. All right, so now my nitrogens are balanced, but my hydrogens are not balanced. So I look at my hydrogen here, and I'm saying, well, what can I do to that to make that 6? And the easiest thing I can do is just to put a 3. Let me put a 3 right in the front. So now I'm going to change my thing again to that's 6. So let's see if everything's balanced now. So we still have 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens. So this is balanced. Okay, that's balanced. And so my final equation would read 1 molecule of nitrogen plus 3 molecules of hydrogen gives me 2 molecules of ammonia, or NH3, and nitrogen trihydride. Okay, so we've gone from 2-atom balancing. Now we're going to do 3-atom balancing. Everything is the same as before. We're not changing anything different. We're just taking a little longer to do it now. So let's go here, and we're going to do our 3 here. So start out with H. That's 1. And then chlorine. That's 1 too. And aluminum is 1. Let's go to the other side. On my product side, we have aluminum is 1. So let's just do in the same order. So H equals 2. Chlorine equals 3. And then aluminum equals 1. Now, notice here that the aluminum stands by itself. So whatever I do to this affects nothing over here, because what I mean by that is there is nothing attached to the aluminum. So if I change the aluminum content here, I'm also affecting the chlorine. If I change the hydrogen content here, I also affect the chlorine. But whatever I do to this aluminum doesn't affect anything else over here except, the number of aluminum atoms. It doesn't affect the chlorine, it doesn't find the hydrogen. So we're going to leave that one to last. So now you just got to pick which one you want to balance first. So let's just pick hydrogen since that's the top one. So we have, how many hydrogens do we have over here? We have 2 here, and we have 1 here. So in order to get 2 over here, we're going to change this to a 2. Okay? Now, when we do that, now we've changed this to 2, but we've also changed the chlorine to 2. We haven't done anything to the aluminum. Nothing is done on this side because we haven't done anything over here, right? So now we have our hydrogens balanced and we have our aluminums balanced, but we don't have our chlorines balanced. So what are we going to do? Well, I look at this thing here and I see there's 2 here and there's 3 here. The lowest common factor between the two is 6. So if I multiply this thing that has this 3 in it by 2, I should get 6. And if I multiply this thing by 3, whatever this chlorine has by 3, I should get 6. Now this doesn't always work easily because sometimes the chlorine is in multiple things, but in this case, looking at the equation, I can see that there's chlorine only in one compound on each side. Okay, so let's have with chlorine, right? So let's change that. Now, we've already multiplied this by 2 to get us the 2. So we have to multiply this again by 3 to get 6, because 3 times 2 gives me 6 chlorines. So instead of just leaving the 2 there, we're going to X that out, and we're just going to put a 6 above it. Now that also affects the hydrogen, so that's now 6. Right, but now my chlorine is 6. My aluminum stays the same. On this side, if I put a 2 in front of my aluminum here, now that's going to give me 6 chlorines. So let's do that. That's 6 chlorines. Now I have 2 aluminums. And my number of hydrogens hasn't changed because I didn't do anything to it. But if I put a 3 in front of my H2, that means I get 6 total hydrogens. Right? I went that kind of fast, but you can see what I did here. Right? I didn't leave the 2 there because it wasn't working, so I upped it up to 6. Right? So we're almost there because we have everything balanced except the aluminum. And we saved that one for last because it stands by itself on this side. So if I just put a 2 in front of here, then we're all good. Because now that changes to 2. So everything balances. So my final balanced equation reads 6 hydrogen chloride molecules plus 2 aluminum atoms gives me 2 aluminum chloride formula units, because it's ionic, plus 3 molecules of hydrogen. Now let's go to the last one, which is just as tricky, but I'm going to give you a little pointer here to help you undo this. Now this doesn't always work because it only works under certain circumstances. But it's an easy way to get without having to try to balance everything under the sun. So let's look at this here. This is a polyatomic ion. And I said before, if the polyatomic ion stays the same on both the product and reactant side, or reactant and product side, sorry, we're going to treat it as one thing, right? So we're going to balance it as it is a NO3 unit, right? Just like we would balance a potassium ion, atom, we're going to treat this as an NO3 type of species. So when we do our count, we're going to count it as one thing. So the first count is, what's my potassium? Potassium equals 1. My iodine equals 1. My lead, oops, let's do this down here because it's going to get in the way a second. My lead equals 1, and my NO3 equals 2. Right? There's 2 of them right here. Now, let's go on the other side. We have 1 potassium, 2 iodines. So that's iodine equals 2, lead equals 1, and NO3 equals 1. So 2 of the things are balanced, and 2 of the things are not. So let's pick one of them and balance it. All right. So how are we going to do this? So let's pick the iodide. Now we have 2 iodides here, but only 1 iodide here. So the only way I can fix this is if I put a 2 right here, right? And I ran out of screen, that's why it's kind of bunched up there. So 2 potassium iodides, so that's going to change this to 2. My iodine is now 2, right? My lead stays the same, I didn't do anything else on there. So we've fixed this, the iodines. We still have the leads in balance, but we don't have potassium anymore, and nitrogen's still out. So let's look at here. Let's look at the NO3. We're going to treat it as one thing. So we have one NO3 here and two NO3s here. So the only way to get two NO3s over here is to actually put a 2 in front here. Right, now we have to recount everything. Right, so now my potassium on this, nothing's changed on this side. Nothing's changed on this side because I haven't done anything to this side. But we only have to worry about the other side. So my potassiums have changed to 2. I didn't touch anything of the lead and the iodine one. I didn't touch this species, so none of those species have changed. And the other thing that's changed is my potassium, excuse me, my nitrate. So let's, that is a 2. So now let's see, we've done it, right? We have 2 potassiums, 2 potassiums, 2 iodines, 2 iodines, 1 lead, 1 lead, 2 NO3s, 2 NO3s. So we're good. So the final balanced equation is just as it reads here. 2 potassium iodides plus 1 lead nitrate gives me 1 potassium iodide, excuse me, lead iodide, not potassium, lead iodide, and 2 potassium nitrates. Okay, so here's the part where you're going to try it on your own. There's only 3 of these things today, right? So they start out fairly simple, and they get a little more complicated as we go down. Now the last one should be fairly straightforward. You could probably do that one second. The middle one may give you a little thing, but remember, I told you the little trick I have. If the SO4 stays SO4 here and is SO4 here, treat it as one thing. So you're going to balance it as it is a SO4 thing, okay? And everything else should come into play. All right, so you're going to stop the video, work the problems. I'll have the answers on the other side when you restart the video. So stop the video now. Okay, so here are the answers. Remember, if you don't see a red number in front of the species, one of the reactant or product, that means that there's a 1 there. It's assumed that there's a 1 there. So I've only given you the coefficients that are different than 1. Okay, so if you got these, great. You seem to have mastered this. If you're still struggling a little bit, you can ask questions tomorrow in class or come find me.